bricks, and we'll talk about various topics with the bricks. We'll then go into preservation issues, what to look for in historic buildings in relationship to the bricks. Now, except for wood, brick is the most common material used in constructions. Brick is basically a unit of clay, sand, and lime, which can either be sun-dried or fired, or today we have concrete bricks, which we make and we use periodically there. Modern bricks today are 50% sand, 20% clay, 5% lime, 7% iron oxide, and less than 1% magnesium. We have harder bricks today than we had historically. Now, except for the concrete bricks, I'm going to talk mostly about the clay bricks here, because that's generally what we're talking about with historic buildings. Today, they are fired in kilns. You take the clay, you put it into a kiln, and you're generally talking about 900 to 1,000 degrees Celsius that this clay is fired to. Sun-dried bricks are basically put out in the sun, and they dry. And that's the way a lot of bricks in New Orleans were done in the 19th century. There are bricks today which are chemically set, but I'm not really going to be talking about those bricks there. Now, fired bricks are mostly used in New Orleans, or really can be one of the longest lasting building products and materials if properly maintained. If you don't maintain them, you're going to have failures there, but there's no reason why a brick wall can't last for very long periods of time. We've got bricks going back to the times of the ancient Egyptians. We've got all this brick in Europe that's been around for a lot longer than New Orleans has been around here. So if you properly maintain brick, it's a good product, it's a durable product, and will last for a very long period of time. Now, sun-dried bricks were first used about 7,500 years ago, actually 75 BC, in southern Turkey. They were basically air-dried, and they generally put a binder in the clay to hold them together, such as animal hair or straw, to kind of solidify the bricks and to keep it together as they're sun-drying. Fired bricks were first used about 2,900 years BC in the Indus Valley in what is Pakistan today. They began firing the clays, which became a much more durable product. The ancient Egyptians, Greeks, and Romans all used bricks. Romans actually had portable kilns that they traveled with them so that they could make the bricks for the buildings they were building and the roads so far. They just traveled with their kiln and were making the bricks where they needed to be there. We can go to ancient Egypt and see where they painted the bricks there. They were actually carved, the bricks in ancient Egypt and so forth. So brick has been around for a very, very long period of time. Now, the first machine that was patented to make brick was in 1855. It could produce over 25,000 bricks in a single day. The earliest bricks in New Orleans are not going to be manufactured in such a way there today. I've got some examples of bricks we'll see in a little bit later on here and all. Today, bricks can be cored. They have holes in the bricks. Old bricks don't have cores in them. Today, they core the bricks in order to use less material. It's a lighter load than that. Most brick today is used as a veneer. It's not done as structure. The old bricks are going to be very solid in their formation there. Excuse me. Not only do we have the coring, but we also have this frogging on the back of the bricks today, which is quite often used when you're adhering this to concrete block or something else like that. You can make it bind a little bit more. Now, in the United States, the modular brick size is 7 5/8 inches by 3 5/8 inches by 2 1/4 inches. U.S. standard bricks are 8 inches by 3 5/8 inches and by 2 1/4. I got a phone call from Eleanor Burke over at HDLC and said, "Robbie, what's the standard brick size in the 19th century?" I said, "There is no standard brick size in the 19th century. At the time of the building of the Panama Canal," and I've got a quote here, "there was no standardizations of bricks being used in New Orleans. In 1909, it was reported that more than half of the bricks that had come to New Orleans market were made by hand and dried in open-air sheds. In no other locale in the United States was this percentage so high. From August 1904 to August 1905, New Orleans had used over 27 million bricks. 13.5 million was still being handmade. The bricks then sold anywhere from $8.50 to $8.75 per thousand. When they were planning on building the Panama Canal, New Orleans lost all of the contracts because there was no standardization in the early 20th century of the brick size. The government wanted to standardize brick size there, and so New Orleans lost all the contracts. They finally adopted, at that point in time, a standard size of 2¼ inches by 4 inches and 8¼ inches. It didn't exist in the 19th century. So bricks are going to come in a whole bunch of different sizes, and bricks in New Orleans came from all sorts of places, as we will see them excuse me, in a little bit. Now, the very basics of a brick. This side of the brick is called the stretcher. This side of the brick is called the header. Depending on how you lay the bricks up, there are different means. This is from an architectural graphic stance of 1922. If you go to the Beauregard-Keyes House, they have a header, a stretcher, header, stretcher. That is called Flemish bond. The Americans will introduce that into New Orleans. More typically, you're going to find a common bond. You got a whole bunch of stretchers, and then every so many courses, you're going to have a header course. You need a header course because if you're putting bricks together like this, they're going to tend to want to do this. You've got to tie the bricks together with a header course binding it all together. Some of the very earliest bricks in New Orleans were actually 8 inches by 8 inches during the French colonial period. I don't know of any of those surviving other than pavers that I've got. Actually, that's the Spanish colonial period from the Cabildo there. Excuse me. The header is generally almost 1/2 the size of the stretcher because when you're stacking bricks up there, you kind of want it to work with a modular brick joint in the center there. Excuse me. When they bake bricks, sometimes they're made in a wood mold. This is an old wood mold from St. Joe Bricks here. You put the clay in that, it forms the brick on up. Okay? You don't put the wood mold in the kiln because it's going to catch on fire. You take it on out there, and depending on how the bricks are stacked in that kiln, the temperature will change the color of the brick there. If it's closer to the fire, it'll be one hue. If it's away from the fire, it'll be a different hue. Bricks have a range of color to them. They're not all very consistent in appearance there. So you do begin to get this range of colors in the bricks depending on where they're put in the kilns there. The types of clays and the temperature of the kilns is going to determine the color of the brick. The bricks made locally along the shores of Lake Pontchartrain, the first brickyard we're going to see is at the site of the African American Museum in Tremé today. They were making soft red bricks. This is a big brick from the Spanish colonial period. It's very shallow. It doesn't meet the standard modular size of a brick today. You can see a modular size brick here today. It's quite different. They're very shallow. This color comes from firing the clay and it turns to this red color. Many of the early bricks were not fired to high enough temperatures, so there was lots of problems. I'll have some quotes in a little bit where it comes, some of the problems of the French period that they had. The bricks made from along the shores of Lake Pontchartrain were called lake bricks. You'll see these throughout the French Quarter. Lake bricks have these measles on them, these black dots. That is a natural iron occurring in the clays, and when they fire the clay, it explodes. If you cut a section through that dot, you're going to find there's a circular void in there. That's what causes the black dots. These bricks were much more durable than these bricks here. And you'll find different specifications calling for different bricks at different periods of time. We do, however, very early in New Orleans get a whole bunch of imported brick. The majority of the buildings in the quarter today, 1/3 of the buildings date to the 1830s. By 1805, we're already importing brick one in from Philadelphia. The way you lay bricks on up, the bond of the brick, they have different names for it. The common bond, as I said, is you have all the stretches, and every so many courses, you have a header up in there. You have the Flemish bond with the header and stretches, the long and the short up in there. The English bond alternates courses up in that, and there are all sorts of different variations the way you lay up bricks. The majority of the brick coursing in the French quarter is common bond. Some people claim that you can date the age of a building by how many courses that header bond, the bond course, occurs between the stretcher courses. I've never been able to quite figure that on out. There may be some sort of rule of thumb up in that, but I've never been able to quite form that. Now we have the common bond, the Flemish bond, the English bond is the alternating heading and stretcher course. A soldier course is when you lay bricks like this. A sailor course is when you lay bricks like this. You'll find this quite often over doors and things such as that. Sometimes people will find an arch in a wall and they go, oh, there must have been an arch opening up in there. Quite often they put an arch and brick over a flat-headed opening to take the load and transfer it to the sides of the building there. There is, as you go further on into the century, there is something called ideal wall construction. They have two courses of brick, but there's a void in between. It'd be like a three-white wall. And the center portion is a void. It acts like a thermos bottle. I was doing work in Meridian, Mississippi, and all the buildings on the Sanborn maps were marked ideal wall constructed. I had no idea what an ideal wall constructed building was. I went and talked to the oldest architect in Meridian. He had no clue, so I went up to Tulane and started going through all the magazines. Well, there I found the Salem Brick Company had patented the ideal wall construction. And there's actually several homes in New Orleans done this way. And the void, the air cavity, worked like a thermos bottle. It kept the temperatures in the insides of these houses more constant, whereas the outside may be changing a great deal like it happens in New Orleans. It would keep a more relative humidity in the interior of the building there. We have other features on buildings which you will see occasionally. We have something called the belt course. In between the different floors of the building, what would happen was that if they had a floor joist coming in, you got the brick wall here, they needed a ledge, they'll stick it on out. That's how historically belt courses came. Directly across the street, the Ursuline Convent, between the first and second floor, is a belt course. Now, more traditionally, you're going to find in these buildings in the quarter, when you get to a certain floor level, they'll step in the brick one width, and width is the width of the brick here. That would be width. This is a 2-width brick wall there. This would be a 3-width brick wall there. We don't have 4-foot brick walls in the French Quarter. Hear all this, oh, this building's got 4 feet thick walls and all. That just doesn't exist. Maybe the walls in the old U.S. Mint are probably the biggest, and I think they are only approaching 30 inches over there is what I'm told. Most buildings simply do not have that thick of a wall. The Greeks and Romans, when they were laying stone, they never used mortar. They relied on gravity. If mortar was used, it was only a lubricant to slide one heavy stone on top of another. We set bricks today with mortar. Mortar is a very simple composition there. It's sand, lime, and water. Now, there's a problem with today, we'll talk about later on the maintenance of the buildings. People put a lot of Portland into the mortar. People buy these ready mixes, supposedly Beauregard-Keyes formula, way too much Portland in it. You want your mortar to be softer than the brick. It's much easier to repoint a building than to replace your bricks. If you put a hard Portland mortar in it, it'll cause the bricks to disintegrate. So, you want your mortar always to be softer than the bricks. Now, by the time they get to the early 20th century and so forth, they are using very hard bricks, and they are using extremely hard Portland-based mortar. But for most of the buildings in the quarter here, you're talking about soft bricks and soft mortar. So you need that mortar to be very soft. Bricks are laid in different manners. If you see a lot of cornices and bricks are laid on an angle like this, that's called a sawtooth cornice. It's like the teeth of a handsaw. At windowsills, more in contemporary construction, the bricks are done like this. That is called a rowlock course on the buildings there. The corners of the buildings, quite often in Europe, were done with stone blocks. We've got no stone in Louisiana. There was no stone to be had there. So they would fake it out of brick and then apply stucco to it. The Ursuline convent has coins on the ends of the building there. How you put the mortar joints in the building, there's some details down here. How you tool that mortar joint, there's different ways of doing it. You can rake it on out there. You can do it flush. You can do it concave. Over at the Herman Grima house, there's a slight little indentation in the mortar joint. That's because they painted and penciled the brick. They didn't import the brick from the north as the architect had specified. They used the local brick, painted it the bright red northern color there, and they penciled in every joint on the facade of that building so it looked like the northern import brick. When the Americans come in, they want this bright red brick. They want the federal style. It's what Thomas Jefferson used at the University of Virginia and his home Monticello, this bright red brick. Locally, we were stuccoing everything on over. We had gone from the very soft bricks like this to harder bricks like this, but traditionally, they were still stuccoing things on over. In New Orleans, most of the bricks are going to look like this, but they vary in size, but they'll also look like this here. Some bricks will be stamped with the maker's mark in here, and here's a brick here with the stamp of the maker's mark. If you're making a brick column, you get a wedge-shaped brick in here. And so you would have different bricks made for different functions in the building. Now, New Orleans' first brickyard, as I mentioned, was on Bayou Road in what is Tremé today on Governor Nichols Street. This yard produced these very soft, porous bricks, which were very shallow in size up there. The yard produced 400,000 bricks in 2 years and employed both blacks and whites working in this particular process there. The census in New Orleans of 1726 listed only one mason in the city of New Orleans, and there was one lime maker. Now, I mentioned mortar is made with water, sand, and lime. How do you get lime? They didn't have lime. They used to burn oyster shells and clam shells, and these were called burners. And they extracted the lime from the oyster and clam shells, and they would make it. Now, the first buildings in New Orleans probably to use the local bricks was the Corps de Garde, the city's military police force, on the site of the Cabildo, and the first Church of St. Louis on the site of the current cathedral there. They employed brick in between a wood frame construction, which was known as briquet entre bateau. Now, between a short period of time, about 1728 and 1730, they left this brick exposed. The first Ursuline convent across the street of 1734 uses brick between posts exposed, and the building disintegrated. The way they held the bricks into the wood, they just didn't butt it up there. They carved the wood on out so the brick would sit in that and bind better into the post and that, so it simply wouldn't fall on out. And a lot of times the brick, particularly when it got stuccoed on over, was not laid in very random courses, very regular courses. It was sort of almost like rubble sometimes in these walls there. But for this short period of time, they left all this brick exposed, which proved to be a real disaster here in the city of New Orleans. About 1730, they began to do solid brick buildings. The second Corps de Garde on the side of the Cabildo was all brick in there. In 1727, the French governor requested and received masons to be sent to New Orleans because they were in very, very short supply. In 1729, the governor wrote to his superiors that he was working in partnership with the Jesuits in making bricks. So the Jesuits were making bricks here in town, besides the yard that was in Tremé very early. Now, a problem with masonry buildings were reported by local officials in 1751. It was not foreseen that in this country, as human as we are, bricks and mortar would conserve a dampness which would rot the joists out. They're basically saying the walls are so wet that the wood framing going into it would rot on out. What they did was that they would burn the ends of the wood joists and wrap it in lead and then stick it in the masonry. Moisture in our walls have always been a problem. From the rain, from the rising water out of the ground there, with rising damp and so forth. An official wrote to the king that the brick was almost bad that was available here in the city of New Orleans. Mortar here was worthless. There was a serious lack of lime, which when they had was very sparsely used, and the little that was used in the mixture lacked any consistency. They basically, the sands that they were using wasn't good sands from like along the beaches and so forth. It was very sandy and rich, and there was a real problem with the bricks and the mortar very early during the French colonial period. Now in 1801, someone wrote, John Pinchard, the bricks are so badly burned that all of the houses are plastered, and being mostly white, they look very elegant from the river. They're basically saying the bricks are so bad they've got to stucco all the buildings in order to protect the very, very soft bricks. Now, bricks very early are begun to be imported on into the city of New Orleans. A local newspaper wrote in 1804, just arrived for sale, 8,500 bricks from Philadelphia. The New Orleans product list for the city of New Orleans listed in 1805 that Philadelphia bricks cost anywhere from $2 a thousand to $12 a thousand. In 1810, the Courrier de la Louisiane reported that Nicolas Jean Pierre, at his St. Claude brick factory near the Bayou Gate in Tremay, was making bricks, square and of all sizes. He was charging $10 per thousand back then. In 1810, we got 15,000 bricks in from Germany, 10,000 bricks in from Baltimore. The ship manifest for 1820s had bricks coming in from London and Liverpool, England, from Havre and Bordeaux and Le Fleur in France. They had them coming in from Rotterdam and Holland. In the United States, they were being imported from Salem, Pensacola, Massachusetts, and even Havana, Cuba, was sending all bricks to New Orleans. Cotton and sugar is going out on the boats. The boats are coming down loaded with products, not ballast as you hear. This was ballast on the ship and so forth. This was manifested cargo coming on into the city of New Orleans. Now during the 1820s and the 1830s, bricks came from a lot of places in the United States. In a quick search of the newspapers, I found them coming in from Maine, Mobile, Philadelphia, New York, Boston, Baltimore, Baton Rouge, Covington, Louisiana, which is our lake bricks, Newburyport, Massachusetts, Kennebunkport, Massachusetts, and they were coming in still from countries in Europe, Germany. We had from the United Kingdom, from Spain. We had French bricks coming in. We had Philadelphia bricks. Some of the terminology used in the papers were referred to as Pensacola-fired bricks, French-fired bricks, which meant those were hard bricks, good for fireplaces and things like that. Hard, burnt bricks, good for paving and fireplaces. Philadelphia rub stretchers. I don't know what a rub stretcher means. That's the terminology used. Philadelphia pressed bricks, northern bricks, country brick, and lake brick. We were just having a discussion, Anne Masson and Teddy Pierre and all. I used to always say lake brick and country brick are one and the same. We kind of believe now lake brick came from what is basically St. Joe today along the shores of Lake Pontchartrain. Country brick, we had all of these brick yards all in the suburbs, if you want. There was one along Gentilly Road in the Gentilly area, and those are probably called country bricks. Now, I looked in the city directories, in some of the building or the newspaper reports. In 1820, Benjamin Morgan had a yard in Faubourg-La-Course. In 1821, Mr. Rafagno had a brick yard in Faubourg-St. Mary. In 1822, there's a brickyard in Gentilly. And by 1838, the city directory listed 38 brick masons here in New Orleans, 32% of which were free men of color. By 1870, the city directory only lists 4 brickyards in the entire city of New Orleans. Bricks are being imported. We no longer having the bricks being locally made. Now, you've got these old buildings, and what are you going to do to maintain and preserve them? First of all, you need to look at the building. You need to just open your eyes and look at the building. If something doesn't look right, generally something's wrong there. The mortar in the brick sometimes will go back to lime and sand, and you have to then go back and point all of the bricks. It's a problem we had down here. We also, water is a big problem. We had water coming in which eroded this wall. If you're on that side of the fireplace, look down there at the base, the floor dropped almost 1.5 inches over there. The building was going down, that wall is blown out, the mortar has fallen out of the bricks, and the footing's been eroded there. Underground drainage from downspouts and all can undermine your footing. You need to make sure you've got no water issues from subsurface draining, broken plumbing, and things like that. You need to make sure your bricks are well maintained and that the mortar still has strength to it there. Now you can't get way into the building to do that. I'm on this committee for St. Patrick's Church now, and they came up with this idea. Teddy, I don't know if you know, they have hydraulically pumped the mortar into the building, and I can't tell you how many tons of mortar they've pumped into the building because they've done x-rays and sonar and stuff like this, and there are all these voids in that. I haven't bought into that much maintenance of the building. I think you kind of do the exterior walls, the exterior surfaces, you go back and get the bricks put into place. But you need to make sure that your mortar is good. A lot of times people will take the siding and plaster off of a building and expose the soft brick and it'll disintegrate. Big mistake. A lot of brick in New Orleans was not intended to be exposed, such as the soft red brick. We had a problem in the driveway over here that Teddy took care of. It simply started to dissolve. You had a question back there?
Yeah, John.
Yeah.
I don't know if you're familiar with it or not, but Jackson Barracks, those were the 1830 buildings.
Yes.
There's a product called OH Stone Strengthener that you can apply that soaks into the mortar inside the walls. And, you know, we did like 18 buildings down there. It's very successful.
I use a lot of Prosoco's product, which will consolidate brick, will strengthen the brick and so forth like that, and I like it a whole lot. You need to make sure what you're doing is not causing more damage. You don't want to use any water repellent on a building. You don't want to give it no elastomeric coating and so forth like that. But there are products that can strengthen the bricks. But a lot of brick was not intended to be exposed. And so don't expose it. People like seeing the brick between posts. They think it's very quaint, very picturesque. But it's not good for the brick because it's going to sort of self-destruct in those buildings there.
It revitalizes the mortar too in the inside of the walls.
Really?
Yeah, like we're doing a building downtown right now, the Dutch Kerrigan building.
Uh-huh.
And I cut into the wall today. It is totally powdered.
Right.
So, you know, in the inside of it. So.
Some of the buildings I had problems when I was doing Touro Synagogue on over, and you'll see some buildings in the quarter like this. They have very, very tight joints. They're called butter joints. If you're laying a brick, they just sort of butter the edge of the brick because when they go to squish it down, they need them to come together real tight there. And if you put a full set bed of mortar, you're not going to get that tight. And there's a void in the interior there where moisture and all is going in that. To re-point something with butter joints is very difficult. You need a really good mason to get in that because they're going to cause a lot of damage there. If you have a building that's been repointed with a hard Portland-based mortar, you need to be very careful in that, and you need to, I call for saw cutting it, then hammer out the rest of the mortar so you're protecting the brick. You need to be very careful for that. I did a project in Natchez, Mississippi. I couldn't pre-qualify my contractors. I could post-qualify. I did my due diligence and nobody would tell me anything about this guy. They all said, yes, he did the work. That's as far as the architects would tell me. The state was pushing it big time. This was done from one of the garden clubs up there. Specifications and all. I met with the guy before we started the work and I said, okay, this much on the building here, you're going to give me a sample of tuck pointing. Over here, you're going to show me removing the paint, and I cordoned off the area. I went on over to Pensacola for the weekend, and I get these frantic calls. The guy has ruined the building. He has taken an electric saw and gone not only horizontally, but vertically through the bricks, and he cut through all the bricks there. We went on over, we sent one of the other partners over to shut the job down. So we go, what were you doing here? You were only supposed to do this much sample, but yet you did the whole building there. Well, I was going to have to do it anyway. They wanted me actually to fire him while I wasn't even in town. I said, listen, we shut the job down. We got to be fair to the guy and see what was going on. We don't want a lawsuit on this thing in here. Well, he ruined all the brick. We had to actually have all the brick custom made to replace the brick in that. You got to get the right person knowing what they're doing and not destroying your brick there. When you're repouring the brick, I'm always screaming because a lot of times masons today will smear a paper, not a paper bag, but a burlap sack over the brick there. Go look at the mess that they did on the synagogue on Jackson Avenue and the paint company they did at the foot of the Jackson in Chapatula Street there. They ruined the brick there because they were not experienced in it. They lost their tax credits on it because they ruined the building. They were calling me, the architect from Baton Rouge, how can I save the project here? My client's going to go belly up if he loses the tax credits. Well, we tried some things to get it on off there, but you don't want to create the problem to have to solve the problem. You want to make sure it's being done correctly the first time. I'm always screaming, I want to see the full face of the brick. I do not want the mortar coming over the brick there. It's very important to see the full face of the brick, and that's what the Secretary of the Interior is going to want. That's what the SHPO is going to want. There are some things free and available online that can help you with maintenance of it. The Beauregard Commission has guidelines for exterior maintenance. They also have an old book published on the maintenance of brick buildings. The National Park Service has assessing, cleaning, and water repellent treatments of historic masonry buildings. They're going to tell you in here, don't let anyone sandblast your building. Your brick will be ruined. You're going to lose whatever hard surface you have in exposing the softer interior core. Now, at Chartres Synagogue, we did soda blast the building. Not sand, but soda blast it. We did a test area. It didn't affect the brick there. I've heard of a conch shell blasting of the brick and things like that, but you don't want to do it. This thing will tell you here, you don't want to do that. You don't want to put a waterproofing agent on your brick. That will destroy your brick. It's going to keep the water trapped in there, and it's going to then explode the face of the brick there. Or it's forcing the moisture into the building, and you're going to have problems when you plaster there. You can put a water repellent, like Teddy and I used at Lafitte's blacksmith shop to save the bricks over there. It's breathable. It met the Park Service requirements. It met the VCC requirements. But it didn't cause the problems that waterproofing can do. For a while, they were waterproofing everything. After the floods in Florence, they put waterproofing over all the statues, the marble statues. They started falling apart because from the interior, they started disintegrating. Don't put elastomeric coating on your brick or your stucco, period, amen. I am spending now $1.2 million to remove it off the Cabildo. I don't know if you noticed, but parts of that building started falling into Jackson Square one night.
Yeah.
Ursuline Convent's got it on. They're trying to take it off of Christ Church Cathedral on St. Charles Avenue right now. They are having the problems there. They put it on the Old State Capitol in Baton Rouge. Toxic mold started developing in the building. This was billed as the best thing for your masonry building. It's going to save everything. What it does is that water gets trapped behind. It's going to get in the building, either from the groundwater coming on up, or it's going to find its way. It's going to crack. It's got to come out somewhere. It explodes the face of the building off, and that's the damage. I'm completely removing the elastomeric coating off the Cabildo. Davis Lee Jenke is the architect for the Presbytere, and is removing it off the Presbytere. One of the biggest mistakes you can do is put that on a building. These waterproofing companies are going to try to convince you to do it. Don't do it. You're going to have more problems and more expenses down the road. Water repellents, the brick consolidators, yes. Don't use anything like a waterproofing and all. In this preservation brief here, free online, this is preservation brief number 1 from the Park Service available. Preservation brief number 2, these were the first 2 preservation briefs that they did were about masonry. Here we've got repointing mortar joints in historic masonry buildings. It is going to tell you to use a very soft mortar mix. The Beauregard today will allow 1 part Portland, 3 parts lime, and 9 parts sand. Some people, and Teddy was just telling me about a project he was doing with no Portland in it, all lime base and that, and a lot of people arguing for that. I haven't gone that way, and the reason being, when I did Camp Parapet in Jefferson Parish at the foot of Causeway, I used virtually no Portland in it. Mason pointed it one day, it rained the next day, all the water washed out of the building. It hadn't set up there. I know some people are going to no Portland in it whatsoever, but do not buy those pre-mixed bags that says Beauregard-Keyes formula. They have high Portland in it. When I questioned it, I did it for the Historic New Orleans collection. They wanted to use it. I said, okay, give me a sample in here. They came on up there. I couldn't get my key, a knife, or anything into it. It was hard as a rock. I said, okay, I'll get the Beauregard Commission over here. They said, no way, that's too soft. So I called up the company and I said, what's in your mix? And they go, I can't tell you, that's a proprietary. Well, then how can you tell me it's matching this formula in here if it's proprietary? It is extremely hard, and I will not let anyone use that on my jobs. I always make them mix it on the job site. If someone comes up with something that's going to follow the formula, great, but you need to use a soft mortar in there. Now, there's also preservation brief number 38. I think you saw on the news where the Ursuline Convent and the Beauregard-Keyes House were both hit by graffiti. How to remove graffiti from historic masonry buildings. The Park Service also has, in respect to the Secretary of the Interior stance, a lot of free information. The longevity and appearance of a masonry wall in here. And it talks about problems with masonry walls, do's and don'ts. If you're doing a Tax Act project, you're getting tax credits, either state tax credits or federal tax credits, you have to follow all of these briefs. In my specifications, I'll actually cite these briefs in there. Rising damp is a big problem in buildings in New Orleans. It's the water in the ground coming on up. People complain very early. One of the reasons, suppose they're using armoires in New Orleans, is because the walls are sweating so much. Anne, when she teaches her classes, talks about the walls constantly sweating in town. I'm doing Our Lady of Good Counsel on Louisiana Avenue. When all this humidity came in, I go into the sanctuary and I said, who spilled all the water in here? They go, nobody spilled anything. That's just the condensate that's dripping from the ceiling and the walls and everything in here. They complained about the walls sweating so much that you put your clothes, your food, your papers in an armoire. It's sorted in a wood box with the air circulating all around. You're not in a sweaty masonry wall up in there. Water's going to come up, and today when we have air conditioning in buildings, air conditioning is dehumidifying. What is it doing? It's sucking the water out of the ground. It's got to go somewhere. So then you start having efflorescence on your walls. Your plaster starts falling off. You see all this white powder on your plaster or on your brick there. It is rising damp. Historically, the way they did this, they come on up, they put slate in that. It's the damp course. The problem is that the paving has come up and up and up, and the damp course has been violated, or the slate has just turned to mush there. One way of doing it, you saw all through your building there, and you put a copper barrier in there. That's your new damp course in there. That's very expensive to do. You drill in from one side to the other side. Today, we use chemical damp coursing. They pump chemicals in it that creates a damp course there. The Park Service uses it at the Chalmette Battlefield. We use it at the Petit Salon. I'm proposing it for the Cabildo. I don't think it'll get done because we don't have the money there to do it. I did it at Destrehan Plantation. I've done it in some areas. Now, I do understand they did it at the Mint. It was not successful at the Mint because the walls were too thick. They couldn't get the chemicals from both sides to create a barrier, so it was still rising in the core of the walls there. But chemical damp coursing is something which can be done to keep the rising damp on up. But it is a tough problem. I got to tell you, it's hard to solve, and you've got to stay on top of it and look at the issues. Our office did some things that we would never do today. We put mastic on the walls. We put the hard Portland cement on the walls. All it did was drive the water further up into the walls. Our philosophy today, deal with it low. At St. Patrick's, I've actually, at the Gallier House, I was there today. They had moisture problems there. I said, we're going to undercut the baseboards and let it vent there. Keep it low, keep the moisture low, don't drive it into the wall. You have a question?
Yes, on the wall, it's on the parapet. They've been putting copper and galvanized. Could you use the chemical on the tops of the parapet?
It's keeping water from migrating. And when I'm thinking of a parapet, you're getting water coming in from all sides, and I don't know whether that will work. Now, the Beauregard Commission does not like cap flashing. It's not permitted. You've got to take those, we'll put a through the wall flashing up at the top as a way from stopping the water coming on down. Historically, sometimes they would use a porridge coat up there to stop it, but that is a problem up there. A lot of people just cap it, and then they get cited by the Beauregard-Keyes Commission for violation of their regulations up there.
Yeah.
But I don't know, I've never heard of anybody using, if you, Teddy, using a damn course up on a parapet at all then? I've never heard of that being used there. It may be something that I use a lot, Richard Voca. I'm not promoting any company here or whatever, but Richard Voca does a lot of my water issues on buildings. He just did the chemical dam course at the Gallier House. In fact, the Freemans told me when they lived there in the 60s, the wall had problems back there. The office tried putting mastic. They tried doing all these solutions. I have now just completely had the back wall completely tuck pointed, and I put the chemical dam coursing along that wall in that. We removed the baseboards, put the holes in the baseboard area there, and then we recovered it over in there. So that is a way of kind of taking care of this rising damp. It's not always 100% successful because not all of your water is going to be rising damp. You're going to have other issues which you need to look at. Cracks in the building. At the Herman Greenman House, we just spent a fortune. Over the years, they put plumbing on the exterior, electrical on the exterior, gas lines on the exterior, phone lines on the exterior. And every time they did that, they put a penetration in that brick wall there. And all those holes was allowing water into the walls, which if we had a damp course there, would be on top of it. There'd be no way of controlling that. So we got as many of those penetrations off the wall, get all that stuff off your wall so you're not having to deal with those particular issues. Keep the vines. I know a lot of people like vines on their buildings. It looks very picturesque and all, but the vines and ferns are very, very bad for these buildings because the roots get into the mortar. In fact, it happened over at the Herman Greenman House. The whole top course of the brick wall fell off because of the vines there. Luckily, it didn't hit any tourists going through on the tour of the house there. You got to be careful of that. I understand the city's been citing a lot of people for vines growing out of their buildings, which I never thought they had enough time to do that. We got buildings falling down in the French Quarter. They're going around citing buildings for the ferns growing out of the buildings. And I don't know how you cure ferns growing out of the building. There are spores in the air. It'll find anywhere with the moisture in the air. The ferns are going to start growing all over the place. You just need to start staying very aggressive with that in there. I've got a couple of quotes from some building contracts in the French Quarter here, and I want to read some of these to you. This is an 1831 building contract. It's going from the foundation all the way on up. Now, generally where the foundations were done, they would dig a trench in the ground there. Quite often the specifications call for barge boards at the bottom of the trench. Specification for the Pentalba buildings called for it. The U.S. Custom House calls for that in there and so forth. The French colonial period, they used things which are bigger like railroad ties. I'm not quite sure why they did it. My best guess is they're digging a hole, it's filling up with water, and they needed a level base to lay the bricks because in the water that's going up and down, you never get your coursing level there. The wood would kind of give them a level base and so forth. As long as that wood is below the water table, it's going to last for a very long period of time. We found the wood underneath the footings for the French colonial prison on the side of the Cabildo still intact in the courtyard of that building there. You could pull up boats from the time of Christ in the Mediterranean. You got to keep it in water there. You go into some of these Civil War battlefields and all, and they'll show you the boat they brought out of the Mississippi River, but they're constantly drenching it in water there. It'll last for a long time when it's in the water there. For this 1831 contract, it reads, the foundations of all the inner walls to be 4 bricks thick, which means 8 whites. Okay, this is the foundation now. At the bottom, reducing to the thickness of 2 bricks, 8 inches thick there. The house is to have 8 good fireplaces made in 4 separate chimneys, the tops of which are to be built with Philadelphia or Baltimore brick. What's exposed, they want to see that northern imported brick. What's in the walls, they're not too concerned about the construction there. The front of the house is to be cased on the outside with Philadelphia stretchers and laid neatly in a Flemish bond and white border. There is to be a plain, neat brick cornice in the front plastered and the brick cornice in the rear not plastered. The front, however, as before stated, is to be laid in a mortar made of white, sharp sand, and all the joints on the outside of the house are to be struck plain. That's the tooling of the joint in there. With the exception of the front of the house, where the joints are to be cut. And cut means they're creating, there's an example of a cut in here, in which you're creating a little bitty incised part up in that to do the joints in that. This is for a house in Burgundy Street, 42125 Burgundy Street, built in 1840. The foundation's 5 bricks wide. That's not meaning 5 times 8, that's meaning 5 times 4 going across up in that. It's the width of the bricks. At the bottom, prepared and built up in the manner of foundations for a similar house. All the walls to be 1 brick thick, that means 8 inches, 2 wides up in there. Commencing 3 bricks above the foundation. All the bricks of the best quality from over the lake. That means lake bricks there. Except for those which will be required to be built of the chimneys in the back house, which are to be built of country brick. As I said, I used to always commingle lake and country bricks here. They're making a very specific distinction between lake and country bricks being used. The whole to be laid in a good workmanlike manner with good, fresh Thompson lime. And Thompson lime is used a great deal. It was a manufactured lime by the 19th century that they're using a great deal here in the city of New Orleans. So those just gives you some ideas of some of the specifications. So the walls generally aren't, 30 inches thick. They're kind of narrow. The taller the building, the wider it's going to have to be. As I mentioned, sometimes as you go up, there'll be a step in. You will find tie rods in buildings. Some tie rods are retrofitted, like in the Ursuline convent. They took the heavy fringe tile roof off the building and during the Spanish colonial period put wood shingles on the building and put the tie rods to hold it into place. Other buildings, the tie rods are built in with the actual construction to anchor the building. I'm working on a building on Ursuline Street right now. The problem is, with a lot of the brick walls going in this direction in here, the front walls, all the joists are parallel to